let's see how we would find the vertex and intercepts of y equals x squared minus 6x plus 8. And even though we weren't told what this is, we should recognize this as a parabola because it's the one quadratic equation that we graph that only has an x squared, but it doesn't have a y squared in the equation. In the circle, in the ellipse, in the hyperbola, we have both x squared and y squared terms. We had other terms besides, but specifically those two terms appeared. But in the parabola, we do have an x squared term. We have an x term also, but the important thing is the x squared, but we don't have any y squared, just have a plain y. So we know this is a parabola, and we know that in this case, the a, the number in front of the x squared, the leading coefficient is 1. The b is -6, because that's in front of the x. And the c is 8. And when we want to tell, remember, a parabola is an U-shaped object. And since the leading coefficient is positive, this is going to be a U-shape opening up. Again, we remember it looks like a smile, and that goes with the fact that the A is positive. If it's negative, then it's a frown. It's a hint as to how to remember this. So what we're going to first find is the vertex, so that we'll know once we have the vertex. And literally, if all you're asked to is sketch the graph, you don't even have to find the intercepts, because just the vertex with the factor that it opens up or down will tell you approximately how that graph would look. Also, if A is 1, it's a regular size parabola. If A is something like a half or -1/2, just it's less, a number less than 1, the parabola gets wider. If A becomes a bigger number like 2 or a -2, it's a bigger absolute value, then it gets narrower. So we can really have a good idea of what this parabola is going to look like even before we start to graph it. Okay, if you recall, the way we find the vertex of the parabola is we do x equals -b over 2a. And that'll give us the x value of the vertex. The vertex is a point, so you're going to need to find the y as well. Well, -b over 2a is -6 over 2 times 1. Which, so a negative and negative is positive. It's 6 over 2, which gives me 3. And now we'll figure out what the y value is by replacing the x, which we know, and the vertex is going to be 3. We're going to find the y value by putting it back into the equation. So we're going to do 3 squared minus 6 times 3 plus 8, which is going to give us 9 minus 18 plus 8. And when you combine all of that, you get -1. So my vertex becomes the point +3, -1. If I were going to graph this, it didn't ask me to graph it, just said find the vertex. But if I had wanted to graph it, here would be +3, -1. This would be my vertex, and it would be, say, opening up from that point. We also wanted to find the intercepts. So there are 2 types of intercepts. There's the x-intercept, and there's the y-intercept. Now, the parabola of what we call a vertical parabola, a parabola that says y equals, there will always be a y-intercept. Sometimes there will be x-intercepts and sometimes not. And in that, there could be even up to 2 x-intercepts. There's always going to be one y, and you could have 0, 1, or 2 x-intercepts. Let's work on the y-intercept. First, we find it by setting x equal to 0 in our equation. So that'll give me 0 squared minus 6 times 0 plus 8, which is just 8, because this is all 0. In other words, the C is going to give us our y-intercept. It's almost like the y goes on x plus b, and the number that stands alone, that's not next to x. The b is the y-intercept. Here it's the C that stands alone. That's your y-intercept. So 0, 8 is your y-intercept. If I want to graph it, I go up 8 on the y-axis. And this would be my y-intercept. Again, I can say the y-intercept is 8, or I could just say it's 0, 8, which is a more correct way of putting it. The x-intercept we find by setting y equal to 0. And if I look at my equation, that'll give me then 0 equals x squared minus 6x plus 8, which is a quadratic equation. Now we know with quadratic equations, you usually get 2 answers. That's why you get 2 x-intercepts. Sometimes the 2 answers are the same number. In that case, you'd only have 1 x-intercept. And sometimes when you go to solve a quadratic equation, the answer comes out to be something with I. In that case, there are no x-intercepts. So that's the case where you might have 0, 1, or 2 x-intercepts. In this case, this is easily solved by factoring. You don't even have to, otherwise we could use either the formula or the completing the square method, but we don't have to. This factors to x and x. The last term being plus means both signs are the same. They both have to be negatives. And what multiplies to 8 and adds to 6 is 4 and 2. So we get x minus 4 equals 0, which gives me x equals 4. And x minus 2 equals 0, which gives me x equals 2. So my 2 x-intercepts are 4, 0, and 2, 0. Again, you could say the x-intercepts are 4 and 2, but the better way is to write it as a point 4, 0, and 2, 0, because your y would be 0. So if I put that on my graph, here's 4, 0 is here, 2, 0 is here, and I get a graph that looks, this should really be coming out further. And that's what your parabola would look like. Notice we got a good look at it if we just had the vertex, but putting in the x and y intercepts made it a more exact picture. So this is the last thing that we had talked about in when we were here on Tuesday. That takes care of our conic sections. Remember, the conic sections are the 4 shapes that we get when we have some sort of quadratic equation that we're going to be graphing. We don't get a line. That's when we get a linear equation. That's when the highest exponent is 1. But when our exponent is 2, we could either get a circle, an ellipse, a hyperbola, or a parabola. And we saw in what instances we got which kind of figure. Those 4 figures are what we call the conic sections. I'm going to stop here now, and I'm going to go on to our next topic. This finishes chapter 9. We're now going into a topic called trigonometry. Trigonometry is not in the textbook. If you look for it, it's not going to be in the textbook. You're going to have to just listen to the lectures. We're just doing a very brief survey of trigonometry. We're going to see what different terms mean and how to figure them out. We're not doing any difficult problems trigonometry, because if you're going on to pre-calculus, you'll spend almost the whole term learning trigonometry, because there's a lot more to trigonometry than what we're doing here. After we finish trigonometry, we have one more chapter to do in the book, which is chapter 8. It's called Exponential and Logarithmic Equations. We're going to do that as our last topic. After today, we have a total of 4 lessons. This is the end of pretty much the end of the term. Don't forget to do all the material that you have to do to get full credit for your homeworks, for your tests. If you're missing anything, if you can, or if you want to, let's say you want to redo something. If you want to redo your practice midterm because that was a test on Blackboard, just email me. I can always reset it so you can start it all over again. But you have to let me know. I've extended the due date for the Delta Math homeworks and tests to December 5th. Everything has to be completed by December 5th in any case. There is, if you didn't do it by the original due date, you can still do it with 90% of the credit. Make sure, don't leave this all for the last minute. If you want to get as much of the 40 points that you can get before you step into the final. The final in this course is worth 60 points, and you want to be able to get as much of the 40 other points. Remember, 10% is the midterm, 20% is the quizzes and tests, and 10% is the homework, which adds up to 40%. You want to get as much of that 40%. You want to get 38 or 40 or at least 35 points on that, so that it raises your mark for your final, that you don't only get it from the final. In any case, even if you got 100% on the final, it's only worth 60 points. So if you did nothing else here, you'd be worth, and you got 100 on the final, you'd get 60 points, but that's not a passing grade. A passing grade has to be 70 points. So make sure you get everything finished timely. Okay, so the final passing doesn't completely count. If you do nothing else, you won't pass the course. If you got 0 on everything that I gave you in class, and you got 100 on the final, you'd only have 60 points. And the lowest passing grade for this course is 70. So you need at least 10 points from everything that we've done in class. Now, if somebody, realistically, if you haven't done anything else in class, you're not getting 100% on the final. So it's sort of a moot point to say that you could get 100 on the final where you've done nothing else. This course used to be that your pass or fail depended just on whether you passed or failed the final. And most of us professors felt that that was unfair, not because of somebody who did nothing and then got 100 on the final, but on the other side of the coin, where somebody could be working a whole term and be doing well, and then just miss passing the final, got, let's say, a 55, and that person would fail the course, even though they had hundreds on everything else. That we felt that that was unfair, and in order to alleviate that, the new this way of figuring out marks was to give the final exam 60% and everything else worth 40%. So make sure you get as much of that 40% as you possibly can. All right, the topic that we're going to be talking about today is something called trigonometry. This term we've talked about a few different types of mathematical studies. We talked about algebra. What do we do in algebra? We've learned how to solve equations, solving linear or quadratic equations. We learned how to work with polynomials. We learned how to work with radicals. We learned how to work with i's. All of that is part of algebra, working with numbers. Then we did graphing. Graphing is working with shapes and figures, lines and circles and ellipses, etc. That's geometry. And then there's our next topic in mathematics called trigonometry. Now, what we're going to do in trigonometry, again, is very minimal. We're going to look at the basics. Anybody going on to pre-calculus will spend most of the term doing a lot of different trigonometry topics. We're just going to be doing the basic definitions of the things that we use in trigonometry. What is something called a sine? What is a cosine? That's what we're going to be talking about, and how to find those things. We're not going to learn how to use them too much. All of that is for upper courses. But we are, again, doing a survey, just a preliminary outlook on trigonometry. Now, if you look at the word trigonometry, you will see that there is, first of all, a prefix saying tri having to do with 3. And then there's a suffix that says metri, which comes from the word meter or measure. So we're measuring something that's 3. And if you think about it, the smallest figure, the least amount of sides you can have in any kind of closed figure that has straight sides is a triangle. You need at least 3 sides to enclose a figure. Then you could have rectangles, then you could have octagons like the stop signs, but the smallest amount of sides you can have is 3. So our basic building block of shapes is a triangle. And that's what this tri stands for, triangle measurements. We're going to be looking at how to measure things in a triangle. And once you can do a triangle, then of course you can extend your study to, let's say, rectangles or squares or any other figure, because every figure, if you just have straight sides and you draw their diagonals, you will end up with a bunch of triangles. So that's where this word trigonometry comes from. Actually, the type of trigonometry we're going to be talking about is something called right triangle trigonometry. So what do we mean by a right triangle? This type of angle, an angle that forms a square corner, is called a right angle. In the number of degrees, it's 90 degrees. I'm sure everybody has seen a right triangle. A right angle is all over. Just look at my blackboard. Its corners are right angles. Look at your doors, look at your windows. Unless you have an unusual shape, the thing is going to be either square or rectangle and have these right angles in them. And obviously, if I were to draw the line that goes from this corner here down to that corner over there, that diagonal would give me two right triangles. So really, a major building block of what we use to construct things is really the right triangle. So that's when we start with our discussion of the right triangle. Now, before we even do any trigonometry, there are a few basics that I want to talk about. First of all, usually we use capital letters at the what we call the vertices or the corners of the angles to label the angles of the triangle. This is angle A, this is angle B, this is angle C. Usually the C, if we're using A, B, and C, it's usually the C that's put at the right angle. And we call this triangle by all three names. This is triangle ABC. So you could have also called it triangle CAB. It doesn't matter. You just have to use all three letters as if you want to talk about the whole triangle. Now, we mentioned that angle C is a right angle. It's 90 degrees. In the whole triangle, any triangle, it doesn't have to be even a right triangle, any triangle at all three angles of the triangle will add up to 180 degrees. So if you think about it, if this is my right angle and it's 90, then the A plus the B in the right triangle have to add up to 90 as well. A and B are what we call acute angles. They're each less than 90, and the two of them together will add up to 90, so that all three angles in the end add up to 180. Now, we said that we're using capital letters at each of we call these the vertexes or the corners. That's to give a name to the angle. I can talk about angle A, I can talk about angle B, I can talk about angle C. But aside from the angles in a triangle, even though it's called a triangle, three angles, the triangle also has three sides. How do I label the sides? Well, obviously, if I wanted to talk about this side, I could call it side AC, or vice versa, CA, using both letters to indicate that I'm starting at A and going to C, or I'm starting from C and going to A, specifically this. Now, it's a little bit annoying to have to use two letters when you're talking about a side. If I want to talk about side AB, I have to locate the A, I have to locate the B, and then I know this is AB. It's much easier just to use a single letter. And that's what we sometimes do. But when we do that, we don't use capital letters because the capital letters are reserved for the angles. What we use for the sides is lowercase letters. And it's done in a very specific way. Let's say I wanted to talk about this side BC. If you notice, BC is attached to B, it's attached to C, it's not attached to angle A, it's across. It is opposite angle A. Since it's opposite angle A, we call it small a. So we use the same letters that we used in talking about the angles, except for the capitals are the angles, the lowercase letters are the sides. In this case, since this side is opposite angle B, this would be lowercase b, and this is lowercase c. We also have different names. The side that's opposite the right angle is called the hypotenuse of the right triangle. The other two sides that are not opposite the right angles, but are opposite the acute angles of the triangle, are called the legs. So there's this B that's a leg and A that's a leg. There are two legs and one hypotenuse in our right triangle. The word hypotenuse only is used in a right triangle. You can talk about the legs of a triangle even if it's not a right triangle, but hypotenuse must be a right triangle. Also, let me just, there happens to be a very important equation, formula, theorem, whatever you want to call it, that gives you the relationship between the three sides of the right triangle. This only works in the right triangle. That a squared plus b squared equals c squared. Notice I'm using lowercase letters, so I'm talking about the sides. This doesn't have anything to do with the angles. The only thing we must have is that one of the angles, the angle C, is the right angle. And we square each of the legs and add it, and that'll give us the hypotenuse squared. This letter over here will always have to be the hypotenuse. Even if it's not labeled A, B, and C, if it's labeled other letters, the C, the side that's on the other side of the equation is always the hypotenuse. This formula allows you to know just two sides of a right triangle, and you can use it to figure out the third side of the triangle. It's called the Pythagorean theorem. After the Greek mathematician Pythagoras. It's not important that you know the name of this, it's just important that you know how to use it. But if you notice, this goes back to Greek times, which is where trigonometry was first developed. And as a result, what we also sometimes do is, instead of using capital letters for the angles, we sometimes use Greek letters. Most common Greek letter is this one. This thing that looks like a zero with a line through it is the Greek letter theta. And I might talk about this being angle A, or vice versa. I can talk about it being angle theta. What's the reason we use Greek letters is because the Greeks were the first ones who used this type of study. And there is an advantage to us, because if you see a Greek letter being used in trigonometry, you know that that letter represents an angle. They only use the Greek letters to represent angles. They don't use it for sides. So again, just like we're using Greek letters now for hurricanes, we're going to be using Greek letters to name angles in trigonometry. Again, this theta is sort of like the X. The X is the most popular letter used as a variable. Theta is the most popular Greek letter used as a variable. So let's talk about how do we use this Pythagorean theorem. So let's say I have a triangle that looks like this. And suppose I tell you that this side is 5 and this side is 12. I'm giving you two sides of this right triangle, and I want you to find the hypotenuse. So let's call this C. Usually this is the one I call A, and this is the one I call B, because I usually put the A down here and the B up here. That's my standard way of doing it, so I'm going to pretty much be consistent that way. Using Pythagorean theorem, A squared, which is 12 squared, plus B squared, that's 5 squared, will give you C squared. And I work this out. 12 squared is 144. 5 squared is 25. When I add these together, 144 and 25 gives me 169. And since C squared equals 169, I have to take the square root of 169 to figure out what C is. Now, the square root of 169 turns out to be 13. You can try it on your calculator if you don't remember that from doing squares. Notice, really, usually when we have something like x squared equals a number, we get two answers for our x, the positive and the negative. But when we're dealing with the sides of a triangle, the sides of the triangle don't make sense to call them negative. And there's no such thing as a negative side, so therefore we only use the positive answer. But notice we started with two sides of the triangle. We only knew two sides, but we were able to use the Pythagorean theorem to find out the third side. Now this Pythagorean theorem only works in a right triangle. As a matter of fact, it's even sometimes used as a test for a right triangle, because if you can do A squared plus B squared and get C squared, that means that you have a right triangle. Okay, let me see if I can give you one to try. This is not yet trigonometry. This is the Pythagorean theorem. It's a step before we do trigonometry. I'm going to give you a triangle. I'm going to ask you to figure out one of the sides of the triangle, and while you're doing that, I'm going to take attendance. So here's my picture. And I'm going to call this side 15. And this side is going to be 11. And I want you to find this side. See if you can find that third side of the triangle. If it doesn't come out evenly like this, if it comes out to not a perfect square, then write your answer in radical form. If you can simplify it, simplify it. Okay, so we want to find the third side of this right triangle. Now you don't have to do this, but I like to label the triangle with letters. So I always put my C at my right angle, and I like to put the A at the bottom and the B at the top. You don't have to do it this way. This is the standard way that I usually do it. And using the lowercase letters, this is my small a because it's opposite of capital A. This is my small b because it's opposite the capital B. And this is my small c, my lowercase c. And remember that a squared plus b squared equals c squared. So therefore, we're going to have a squared plus 11 squared equals 15 squared. It always turns out that the longest side of the triangle is the hypotenuse. So working this out, this gives me a squared. 11 squared is 121 equals 225. That's 15 squared. And I want to get the a squared alone, so I'm going to subtract 121 from both sides. So that'll give me that a squared equals 104. And that means that a is the square root of 104. Is that what people got? Now, great. So we got that this is equal to 104. Now, if you recall with radicals, there are two ways of writing radicals. Usually, unless we're told, we leave our answer in radical form. That means inside the radical. If we can simplify it, then we break it up. And in this case, you actually can break it up into the square root of 4 and the 4 into and 26. Which means that I could really write this as 2 radical 26. In the simplest radical form, side A is 2 radical 26. You have to look at if it's a multiple choice question. First of all, if it says find it in simplest form, then you do have to simplify. If it doesn't, then you don't have to simplify it. You could have left it just the square root of 104. Also, sometimes they say give your answer, let's say, to the nearest 10th. If you're asked to give it to the nearest 10th or the nearest 100th, that means they want a decimal equivalent. Now, 104, the square root of 104 is an irrational number. I can put it into my calculator, and when I do the square root of 104, I come out with 10.1980, and there's a bunch of other numbers. It's irrational, which means it's a non-ending, non-repeating decimal. If I ask you to give it to the nearest 10th, that means I want you to round it off. It's not going to be an exact answer, but sometimes in terms of a triangle, it might more sense to see how actually long it is. And if I wanted to round this off to the nearest 10th, I would have to look, here's the 10th position. I look at the next number, which is a 9. As long as it's 5 or more, I have to round up. So this to the nearest 10th would be 10.2. So in regular radical form, it's a square root of 104. In simplest radical form, it's 2 radical 26. And in decimal form, to the nearest 10th is 10.2. Again, it depends on what you are asked to find. But this is how you use the quadratic, the Pythagorean theorem to find the third side of a right triangle. Any right triangle, can you give it to any two sides of the right triangle, you can figure out the third side using this formula. Okay, with that being the case, we're going to now go on to the trigonometry. What we're going to be talking about in trigonometry are what we call the trigonometric functions or the trigonometric values. And there happen to be in every right triangle a total of 6 of them. 3 primary trigonometric functions and 3 secondary ones. Let's look at a triangle and let's talk about what these values are and how do we find them. So here's my standard right triangle, ABC, small a, small b, small c. Different numbers, it doesn't matter. We'll do it with in general, and then we'll go to specific numbers. Again, we could call this angle theta A, or sometimes we can call it theta by the Greek letter. It doesn't matter which you call it. And you'll see it done both ways. Most of the time, I will use regular capital letters. But if you look on a test, you might see instead of any A, B's, and C's, you'll just see this Greek letter. It means the same thing. It's just a different name for the same angle. Okay. The 3 primary trigonometric values are called the sine, which is abbreviated SIN, the cosine, which is abbreviated COS, and the tangent, which is abbreviated TAN. Each one of these represents a fraction, a ratio of 2 sides of the triangle. You're going to know the 3 sides of the triangle. If you don't know all 3 sides, you'll know 2, and then you can figure out the 3rd side. And then you'll be able to make a fraction by dividing one side by another. And depending on what name you're given, it'll tell you which sides to use. Notice that these letters, if you look on your calculators, you will see a button that says SIN, a button that says COS, and a button that says TAN. So these are things that are used. We're not going to really use them on our calculators. That's for more advanced work, but it's the same sine, cosine, tangent that's talked about there. Now, next to each of these, we will write the name of an angle. It will either be the sine of A. Let me just use the A and not the theta. What's in this case? I can talk about the sine of A, or I can talk about the sine of B. We usually don't use the angle C, the right angle, when we're doing sine or cosine or tangent. But notice, it's not, I can't ask you find sine. It has to be sine and then the name of the angle. Why? Because what the sine is the ratio of the opposite side to the hypotenuse. So let's see what that means. If I look at angle A right here, I have 3 sides. In relation to angle A, small a is a side that's opposite angle A. C is the side that's opposite angle C, which is the right angle. That is called the hypotenuse. So the hypotenuse is always the side of the right triangle that's opposite the right angle. And the third side, A and B are what we call the legs of the triangle. A is the opposite leg. B is the leg that's next to. The term that's used there is adjacent. Adjacent means next to. Now notice both the C and the B are adjacent to angle A. They're both connected to angle A. Side A is not connected to angle A. It's across from it. But C is the hypotenuse, and B is called the adjacent one because it's the leg that's next to it. So we have these three sides, opposite, adjacent, hypotenuse, based on the angle that you're talking about. We're talking about angle A. It turns out in order to figure out what the sine of A is, you have to take the opposite side and make a fraction of it over the hypotenuse. In other words, if I'm using these letters, it's small a over C. Let's write this. Sine is opposite over hypotenuse. Before we do a specific problem, let's go through the cosine and the tangent. The cosine, again, I have to tell you what angle to look at. Let's look at angle A again. The cosine is the ratio of the adjacent side over the hypotenuse. In other words, in this triangle, the cosine of A would be small b, that's my adjacent side, over my C, which is my hypotenuse. In other words, cosine is adjacent over hypotenuse. Finally, we have the tangent, and again, I have to tell you what angle to look at. Again, we're looking at angle A. Tangent is the ratio of the opposite side over the adjacent side. In other words, it would be the opposite, which is A, over the B, which is the adjacent side. In other words, tangent is opposite over adjacent. So each one of these things that we just talked about, the sine, the cosine, and tangent, is just a fraction. Now, sometimes it could be written as a decimal. In other words, you might start with a fraction that's 4 over 5, and then put it into your calculator, and it'll give you a decimal. But a decimal is just another version of a fraction. So these trigonometric functions or values are just fractions. And they're different for each one. Now, obviously, what's the hard part here? If you have the numbers, it's not hard to figure out the values. It's remembering what goes with what. So we have what we call a mnemonic device. A mnemonic device is something that helps you remember without having to study very much. So look at what I had written down. I wrote down TOA. How is this a numeric device? Because it's telling me the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over adjacent. So if I ask you to find something that has to do with tangent, I think tangent is TOA, and TOA is opposite over adjacent, and I'll remember how to do the tangent. So how do we remember this word, SOHCAHTOA? So I always think it's, when you want to remember something, if you can have a visual picture of something, it's sometimes more, it gives you a better view than if it's just words. So SOHCAHTOA, I think of somebody in a really cold day like today, coming in out from outside. They didn't wear their boots, so their feet are freezing. So they take a bucket of warm water and they stick their feet in the warm water and they SOHCAHTOA. Again, picture somebody soaking their feet, and you'll remember the SOHCAHTOA, which will help you remember how to do sine, cosine, and tangent. Now let me do an actual problem so that you'll get the idea of what you're supposed to do. Let's say, I'm going to start with a simple one and then I'll do one that's a little more complicated. Suppose I put your angle theta over here and I put 6 over here and 10 over here. I have a right triangle. Here's my right angle. I didn't label it A, B, and C, but it doesn't happen to be. I know that the angle I'm interested in is the angle over here, which I would have usually called A, but I'm now calling by my Greek letter theta. Again, we use Greek letters. We'll know it's, when we see a Greek letter, we know it represents an angle. We never use Greek letters for the signs. Okay, suppose I tell you this. I want you to find tangent of theta. How do I go about doing this? Well, the first thing I'm going to do is I'm going to look at my triangle, and I know I'm talking about trigonometry, so I have to label things opposite, adjacent, and hypotenuse. Now here's my angle. So this is across from it. This is my opposite side. This is my hypotenuse because it's across from the right angle. And this obviously then would be the third side, would be the adjacent side, which makes sense because it's right next to it. And I know tangent is TOA, is opposite over adjacent. And if I look at this, I know what the opposite side is. It's 6. But I don't know what the adjacent side is. I wasn't given that. I was given the opposite side and the hypotenuse. But I just learned my Pythagorean theorem. And I know that the Pythagorean theorem is a squared plus b squared equals c squared. And the c is always the hypotenuse. So this is my a is 6 squared plus b squared equals 10 squared. So we have 36 plus b squared equals 100. And when I bring the 36 to the other side, I get that b squared equals 64. And remember, I'm only using a positive square root. The square root of 64, this happens to be a perfect square, is 8. The adjacent side turns out to be 8. So the tangent, which is the opposite over the adjacent, is 6 over 8. Now, usually if it's a fraction, I try to reduce it. I can reduce 6 over 8. That becomes 3 over 4. If you wanted to, you could then put it in decimal form by doing 3 divided by 4. Again, which format you want it to be in depends on the question and what they give you. Okay, so let's see if we can do another example like this. Okay, I'm going to give you an example and I'm going to ask you to figure it out. Okay, I'm erasing what I have here. Remember, SOHCAHTOA, that I will leave on so you can work it out. Okay, they give me a picture where they put the theta up here. Be careful about that. And they're also calling this, they even put an ABC as well. Here's my right angle. And they told me this side is 5 and this side is 3. And they want me to find the cosine of theta. Okay, I want you to find cosine theta. And they want the answer, if it doesn't, if it comes out with a radical, you should rationalize the denominator. Now I'm going to give you the choices of what it could be. So here are your choices. Okay, so this was they want you to find the cosine of theta. And here, it has to be one of these 4 choices. I'm going to give you a few minutes to try it out, and then we'll do it together. First of all, we want to find the cosine of theta. And I know cosine is so common. Cosine is adjacent over hypotenuse. That's what cosine is. So let's see what we have here. Here's my triangle. Let's label our sides opposite, adjacent, and hypotenuse. So here is my angle theta. The opposite side to theta is this, the one that's across. The hypotenuse is the one that's across from the right angle. So this is my hypotenuse. And the third side, the one that's attached to it, that's not the hypotenuse, that's my adjacent side. Remember, I'm looking at it from the perspective of theta, which is over here. This is opposite now, even though if this was A, this would have been the opposite. That's why I have to tell you what angle to look at, because your perspective of what's opposite, what's adjacent, and what's hypotenuse depends on depends on the angle. This is the theta that they're looking at. The adjacent is over here when your angle is A. Adjacent means next to. This is the opposite, and adjacent can switch depending on what angle you're looking at. For this angle, this is the opposite, and this is the adjacent. For this angle, this is the opposite, and this is the adjacent. That's why it's so important to not just say what is cosine, but what is cosine of which angle. That's why we had to say cosine theta. I didn't just say find cosine. I said find cosine theta, because once you look at your angle, you can tell where then you can label your opposite, your adjacent, your hypotenuse. So we want to find the adjacent, so we're looking for the cosine of theta. And the cosine of theta is the adjacent over the hypotenuse. And I do know what the adjacent side is. The adjacent of this is 5. But it's 5 over the hypotenuse. And I didn't give you the hypotenuse. So we have to figure out what is the hypotenuse. And again, we do it by using the Pythagorean theorem. We do 5 squared plus 3 squared equals c squared. And now we have 25 plus 9 equals c squared. So c squared equals 34, because 25 and 9 is 34, which means that the c has to be the square root of 34. This side is the square root of 34. So even though we weren't told what the hypotenuse was, we could figure it out because we have 2 of the sides. So it turns out that the cosine of theta is 5 over the square root of 34. Now, 34 is not a perfect square. It's an irrational number. So we could leave our answer like this, or if they asked us to rationalize the denominator, if you recall, I told you that really when you have an answer, you really shouldn't leave a radical in the denominator. When your denominator is a single term with a radical, you just multiply the top and the bottom by that radical so that you get as a numerator 5 radical 34, and the denominator radical 34 times radical 34, which is right, just plain 34. This would be your answer, which is choice D. That would be the correct answer. Notice they rationalized the denominator. They didn't leave the radical in the denominator. Remember, you multiply by the conjugate of the denominator if there are 2 terms. If there's only 1 term, then you just multiply by the radical itself. So that's how we would go and do this example. Okay. So now I just want to spend a few more minutes talking about, I said that there are actually 6 of these trigonometric functions. We talked about the sine, the cosine, and the tangent. What are the other 3, the 3 secondary ones? So let me erase what I have here. And talk about the other 3. Let's remind ourselves, the sine of theta is opposite over hypotenuse. The cosine of theta is adjacent over hypotenuse. And the tangent of theta is opposite over adjacent. That's what this is saying. So, katoa. What are the other 3 trigonometric functions? So one is called the cosecant. Cosecant. It's abbreviated CSC. It can't be abbreviated COS because we're already using the COS for cosine, so we call it CSC. The cosecant of theta is just the reciprocal of the sine. In other words, the sine is opposite over hypotenuse, so the cosecant is the hypotenuse over the opposite. I really should use 2 letters for these. In other words, if I know that the sine is 3/5, for example, then the cosecant would be 5/3. Each one of these next three are just reciprocals of ones that we've already talked about. So the cosecant is the reciprocal of the sine. The next one is something called the secant, which is abbreviated SEC. And the secant is the reciprocal of the cosine. In other words, if the cosine is the adjacent over the hypotenuse, the secant is the hypotenuse over the adjacent. Just like the cosecant is the reciprocal of the sine, the secant is the reciprocal of the cosine. Again, this we just use the first three letters because it hasn't been used before. The last one of the trigonometric functions that we have to talk about is something called the cotangent. The cotangent, which is abbreviated COT, is the reciprocal of the tangent. In other words, since the tangent is opposite over adjacent, this is adjacent over opposite. The question is, how are you going to remember what goes with what? We know how to find the sine, cosine, and tangent. We know that from SOHCAHTOA. So here's how I remember it. I'm not going to give you another one of these things. It'll get too confusing. I think everybody will be okay with being told that cotangent is the reciprocal of tangent. It sort of makes sense. It sounds like a cotangent goes with tangent. Perfect. So the problem is the secant and the cosecant. So here's how I remember it. Notice this is an S and a C. This is also an S and a C. This starts with S, this starts with C. This starts with C, this starts with S. And the S always goes with the C. So the sine has to go with the one that that starts with the C, which is a cosecant. Whereas the cosine, which starts with the C, has to go with the one that starts with the S, which is the secant. That's how I remember it. C with S, C with S. Co with no co, sine with cosine, secant, cosine with secant. And that's how I remember it. Let me just demonstrate how you would do a problem with this. And this is where we're going to start on Tuesday. Remember what I said, we're only having class next week on Tuesday because Thursday is Thanksgiving. I'm sure everybody realizes that. No class on Thanksgiving. So we are going to finish up this topic on Tuesday and probably start the next topic by just doing a few more examples. Again, look on Delta Math. I'm going to post something on Delta Math for this type of examples. So let's say I gave you this right triangle. Let's assume this is my theta. Since my theta is here, we'd be careful about where I put the A, B, and C, the opposite, adjacent, and hypotenuse. Let's say this is 7 and this is 15. And I want you to find the cotangent of theta. Now, cotangent, I know, is the reciprocal of tangent. Remember, that's the one I remembered. Cotangent goes with tangent. Okay, so I'm first going to find the tangent of theta. And then I'll flip it over, and that'll be my cotangent. Okay, now what is the tangent? SOHCAHTOA. Tangent is opposite over adjacent. Now here is my angle. This is the angle I'm looking at. So let's label opposite, adjacent, and hypotenuse. This is my opposite side. Notice how it can switch. Sometimes this is the opposite, sometimes it's the adjacent, depending on the angle I'm looking at. I'm looking at this angle. This is the opposite side. Here is my right angle, so this is my hypotenuse. And therefore, this is my adjacent side. And I know what the opposite side is. It's 7, but I don't know what the adjacent side is. I only know what the hypotenuse. So again, I use my Pythagorean theorem. I do 7 squared plus b squared equals 15 squared. So this is 49 plus b squared equals 225. And then I have to subtract 49 from both sides. So we get 225 minus 49, which is 176. So that means that the b has to be the square root of 176. Now, can we simplify that? I think we can divide it by 4. 176 divided by 4 is 44. Oh, I think we can even divide it by 16. 176 divided by 16 is 11. So I can break this up into the square root. Remember how we did this? The biggest square root that goes into 176 is 16. This is 16 times 11. So b is 4 radical 11. If we can simplify a radical, we try to do that. So it turns out that the adjacent side is in simplest radical form 4 radical 11. So my tangent becomes opposite, which is 7 over 4 radical 11. And before I rationalize this, I remember that what I want to do is find the cotangent. And to find the cotangent, I have to take the reciprocal. So the cotangent of theta is going to be 4 radical 11 over 7. So finding the cotangent is just one step more than finding the tangent. All you had to do is take the reciprocal of the tangent once you found it, and that'll give you your cotangent. Okay, don't forget to do as much of your problems as you need. Anything that you have left to do on Delta Math, make sure it gets done properly, on time. Again, if there's anything that you want to retake, let's say you want to retake the practice midterm, which was on Blackboard, just email me and I can reset it so you can take it again. The only thing you can't take a second time is the midterm. If you have not taken the midterm the first time, you must get in touch with me because you must take it in order to get credit. You don't want to go into the final without having as much credit for the course as you possibly can, because you're setting yourself up for failure otherwise. Okay, have a nice weekend. Again, keep looking to make sure you're current on Delta Math.